Okay? So for this one is where yesterday, remember us drawing our little gravitational potential energy and kinetic energy? I want to make sure you understand the difference. Potential energy is stored up, like, for example, like batteries and things like that. That's potential energy. But we're talking about gravitational potential energy. We're talking about where gravity has potentially to drag it down, okay? So yesterday, we drew different scenarios that are back there on the board where different scenarios were going on, like a ball was being thrown up, a softball was hit, there were a car, things like that. So now we're going to do the math here. So let's look at question number 5. Question number 5 said, in the example problem, what is the potential energy of the ball's earth system when the bowling ball is on the floor? Use the rack as a reference level. So if we go back to the sample problem, which is the one before, it tells us the mass is 7.30 kilograms. Gravity is always 9.8 newtons per kilogram. And our height this time is going to be 0.61 meters. So the only thing we have to do is we just have to multiply these three together. So we're going to have 7.30 kilograms times 9.81 newtons per kilogram times 0.61 meters. So if you'll put that in your calculator, and let's see what we get. Please make sure you use the negative because it is a negative height. Put it back in normal mode. And let's see what you got. Yeah. Write it up. Yeah. Bring what you get. There. So we're going to round it up to 44, right? Now, gravity potential energy is in what units? Okay. Let's look at number 6. Number 6 says, if you slowly lower a 20 kilogram ball of sand 1.2 meters from the trunk of a car to a driveway, how much work is being done? So this one, we're doing work. When we're using work, it could be 2 different ones. We can do force times displacement, right? Mass times gravity times height of the final minus the height of initial. Now, we have a mass, 2.2 kilogram. We have the height of the initial is 1.20, and the height of the final is 0 meters. So what we're going to do here is we have to also include 9.8, right? So our mass is 2.2 kilograms times 9.81 times 1.20 minus 0. Whoops, backwards. 0 minus 1.20. There we go. Okay, let's put that in the calculator and see what we get. Yep. Switch back in. Yes, sir. That's fine. Perfect. Okay. So that's number 6. Number 7 says a ball lifts a 2.2 kilogram book from his desk, which is 0.80 meters high, to the bookshelf that's 2.10 meters high. What is the potential energy of the book? Earth systems relate to the desk when the book is on the shelf. So, gravitational potential energy is what we're looking for. We're going to do mass times gravity times height final minus height initial. So our mass is 2.2 kilograms. Our height final is 210. Our height initial is 80.80. And then our gravity is 9.81. So we're going to take 2.2 kilograms, times that by 9.81, times that by 210, minus 0.80 meters. Let's see what you get. .10, sorry. Keep forgetting the points. 2.10 times and minus 0.80. Now we're talking about work. What is that units of? Joules, correct. Perfect. Yes, sir. Yep. Exactly. Perfect. All right, so number 8 is the last one from homework from yesterday. So it says if a 1.8 kilogram brick falls from the ground from a chimney at 6.7 meters high, what is the change in potential energy of the brick earth system? So, change in gravitational potential energy, same thing, right? Mass times gravity times height final minus height initial. So our mass is 1.8, gravity is 9.81, height final is 0, and height initial is 6.7. So what we're going to do, 1.8 kilograms, 9.81 times 0 minus 6.7 meters. See what we get. Please change it into scientific because it's a big number. Yes, sir. Yep. Yes, perfect. Okay. All right. Do me a favor now, take a picture of that and attach it to yesterday's work, since we didn't have time to do that math.